Okay, so now officially welcome here and welcome on our already eighth course in the frames of Smarter for EU project in Ukraine. So today we will speak about sustainable materials and resources. And our speaker will be Dragos Riti. So this is the specialist in this topic, and I want to give the floor traditionally to Eva Merheim-Eyre for official welcome words. And on behalf of Association Energy Efficient Cities, our working package 5 of the Smarter for EU project, and from the whole consortium of Smarter for EU, I would like to say the words of welcome on this last course for Ukraine. After completing this course, for those of you who participated in all the courses, we will prepare the certificates. But about this, we will speak at the very end. And now, Eva, please take the floor for some welcome to our participants. Please, Eva.
Absolutely. Thank you, Volodymyr. This is Eva from Habitat for Humanity, also one of the partners of Smarter for EU. For those of you who are here the first time on these courses, Smarter for EU is an EU-funded program which started in the previous year. It's focusing on several countries in Europe, including Ukraine, and our goal is to be the link, the connection between the developers and the banks, and the project is trying to provide our beneficiaries and interested partners with know-how on how to work with green housing certification, how to make sure that the constructions you are working on has the highest possible standards, and also it's not actually just about the technology and the certification itself, but the ways how the certification can work for you to give you the better conditions financially, how to create these new green funding products together with the local banks. Part of Smarter for EU is also are also activities focused on housing for vulnerable families, and or let's say affordable housing, including emergency housing for refugees, IDPs, and going forward in this program, we would like to not only offer you these types of educational opportunities, but also opportunities to receive with more individual types of guidance and consultations from the members of our consortium. So we hope to be in touch with you more also going forward in this year. So we hope that these courses are really just the beginning of some potential relationships with some of your municipalities or other organizations. I believe today we have here also some participants from not only Ukraine but also from some other countries. I think including Romania. I know we have a few people also registered from other Central and Eastern European countries. So welcome everybody. And now let me move on and present our today's speaker. Dragos Riti is the former president of Romanian Green Building Council, currently a managing director of a premium tech team. And Dragos is going to speak today about the environmental impact of materials, issues such as life cycle of buildings, materials used not only for the construction, but also maintenance and refurbishments of buildings. So we are really hoping to learn a bit more about every step of buildings life, and how to make our buildings a bit more sustainable. Dragos is experienced not only in design but also executions and cost sides of project management of such sustainable construction projects. He in the past worked on various larger and smaller building projects. I believe he's also passionate in this area, also in his private life, while building his personal residence. So he's really the person at the right place to tell us more about the practicalities of sustainable materials. And we welcome him here today among us. So, Dragos, the floor is yours, and please start with the presentation.
Good morning, and thank you for having me here today. Good morning, everybody. Like you heard before, my name is Dragos Riti. I'm from Romania. I've been born and raised here, but I have traveled extensively in my young years throughout the world, and I've been learning a lot of things about building, about the planet, about ecology, and maybe some about some other things. So my background is in engineering. I studied electrotechnical engineering, and later on I did a course, university in psychology. And maybe it's a weird combination, but that helped me to understand how this big ecological system is working and how we as a human can put together things in order to be part of the nature in a natural way rather than damaging the natural habitat. So somehow this course it's looking at this kind of philosophy, how we can use the natural resources, how we can use sustainable materials in order to create an environment where we can live and be in harmony with nature as much as possible. If this is a course that I'm presenting for many years now, and this is a longer course. We'll have only 3 hours today to go through it. And if you feel there are questions or you want to know more or something different, please ask the question in the chat, and Helena, who's doing the translation, will give me the questions and I will answer them. We will probably make a break around 11:30, and that could be a good moment of reflection if there's any question at that point. Like Eva said, I have a little bit of experience in the area. I've been working for many years in the construction industry, and I've been acting for more than 10 years in one of the largest European and Central European banks in Europe. I was leading the construction department, the technical department, and our main focus was to overview the implementation of projects financed by the bank. So that gave me a broad understanding about how budgets are being built and how materials and construction technique have been applied in construction. And with the help of the Romanian Green Building Council, we have helped the investors, the banks, to shift their view a little bit towards the way of approaching construction and somehow put a different weight on sustainability than on profit. We're not there 100%, but I think some big progresses have been made in this respect, not only in Romania, but throughout the world. So coming back to our course, the Sustainable Materials and Resources. This is a course that has been compiled with the help of the World Green Building Council and also with the Spanish Green Building Council. And it's mainly focused on the construction industry, which you will see throughout the presentation has a huge impact on the environment. And this training is designed to provide participants a better understanding of the fundamental of the green building and the sustainable developments. Okay, so this is our aim today. We will go through the course and we'll see there are some learning objectives which to which this course is aimed, but also there are also some things you could extract from it for your personal experience. Okay, so like I said, Green Building, World Green Building Council, it's a coalition of national green buildings with a collective mission to facilitate the global transformation of the building industry towards sustainability through market-driven mechanism. So we are all there. There's more than 90 countries which where World GBC is present, locally, also worldwide. Green Building Council España, this is the NGO who provided data for this course, and at the end of the course there are some case studies which we will not have time to go through it, but the presentation is in the hands of Eva, and I think she will disseminate it and distribute it to everybody which is present on this course, so you can review the course and also get some more information from the case studies. So the question is, why are we looking at green buildings? What's so important? Why it is so important to look at green buildings? Well, because just going through the statistics, globally, the built environment is accountable for 17% of the freshwater consumption, and this is globally. And I would say maybe a little more now. This course has been put together a few years ago, and I think these numbers are a bit different in the sense that they might be higher. Also, it's accounting for 25% of the wood harvest globally, and it's also responsible for 33% of the CO2 emissions in the world. Also, it's an industry that requires a lot of energy to put together the building, and it's accountable for 30 to 40% of energy use. And of course, in order to be able to build, we need some materials, and in order to have these materials, we need to use the raw materials present on the planet. So the building sector has the highest potential to cost effectively mitigate the greenhouse gas emissions, and it holds huge opportunities to stimulating economic growth and has a direct impact on our health and well-being. And this is why the green building councils all around the world are tapping into the potential of the built environment to drive sustainability. And as you might know, there's always a constant and huge demand of building, especially on the residential sector, but also on the commercial sector. You'll see now a lot of demand. And if we are looking globally at the economical environment, and also the effect that the pandemics had in the last few years, but also the war, which is very present now. The shift of the building industry is mainly focused now and will be probably in the next few years in the residential area, but also in the logistical area. So there's a lot of logistical and distribution buildings that are present, more and more present, and there are hubs of distribution for goods for big retailers, big supermarkets. So the learning objectives of this course, I was saying just before, is to establish the relationship between the demands of sustainability and the resource we are using in construction. So, and this is what exactly or what is really needed, you know, to build something in a way that we can have a sustainable building. A sustainable building meaning a less CO2 emissions, a building who can use free energy or green energy, and also a building who can recycle water, but also a building who is built in a manner that it has it can hold thermal energy in a way, not losing due to the construction techniques energy outside of the building. Also, we will be looking at understanding the environmental impact of materials used in construction. You know that in order to have some materials to use in the construction, we need to take some raw materials from the lithosphere, and that creates an impact at the level of the environment once we're doing that. But not only that, it's at the end of the construction cycle where there's also a lot of materials or debris that are thrown back in the environment. We'll also look at we'll have a critical reflection maybe on the typical way of designing, and how using and managing resources throughout the life cycle of the building. And this is something important to look at. A building is not just something that we put together from scratch and then we're using it. A building has a complete life cycle that is impacting the environment. And you will see throughout the presentation what huge impact can this life cycle has on the environment. Also, this course is aiming to propose an evaluation methodology and suggestions for improving the materials used in construction, in maintenance, and the refurbishment of buildings. And also, it shares the knowledge brought from different professional backgrounds and determine the active roles for reducing the environmental impact of materials. So this is the presentation of the course. We will, like I said, we will condense the course in 3 hours instead of 6, but we will go to have an overview of the course, what's sustainability and materials, what's the environmental impact and the strategies, how we're talking about the open material cycle and the closed material cycles. We'll go briefly through the sustainable materials and the building rating tools, which I'm sure you've heard about them. And then we will go and have a showcase of sustainable materials and resources, looking at the closing the material cycle, and also how we can use nature-based materials and how we can improve the industrial based materials. So this is pretty much what we will be doing today. Like I said, we will not go through the case studies, and we'll see if there are any questions throughout this presentation. At any time, feel free to put some question in the chat. Helena will make sure the questions are arriving to me. Okay, so talking about sustainability and materials. So we are looking now at the development model, which is an old model, and this is the current model that we're using. And we know that any human activity demands the use of materials. And our Western model of development, it's based on a constant increase of a new and more demanding needs that in turn require more and more use of materials in order to be satisfied. And if we're looking at the last 20, 30 years, you will be that the technological advance has pushed us from, using phones in a way that we're not used to do that 20 or 30 years ago. And this is constantly a need to produce new components which need more materials. And maybe, or maybe you don't, that there is a shortage of chips for vehicles, because the demand is so big now especially for the new generation of vehicles, that resources are not available at that same rate as it was before. So this model that we're using right now is currently serving as a reference for a constantly growing human population. And this is the backbone of an economy which is spread all over the planet. we're all over part of this. And the problems of this current model is that the materials are extracted from nature, which are causing environmental impacts associated with this extraction, and that diminishes the reserves. And you will see later on that we don't have too many reserves left in the next 20, 30, or 50 years from now. And once the use of the products has been exhausted, so after we're using a cell phone by for example, after 5 years or 2 years or 7 years, the materials are returning to the environment as a waste, often causing serious contamination problems. And this procedure works against a long-term development model. Therefore, it is necessary to create a model that is sustainable. And the question is, how can we do that? Where is the place we can change something or do something different? And actually, this is the challenge of sustainability. The current production model is a process of converting resources into high entropy waste, which destroy the natural capital. And taking on the challenge of sustainability implies doing exactly the opposite thing. It's conserving the natural capital so the next generation can have the same possibilities at their disposal as we have now in the present. So if we are looking of the impact on the environment that the building industry has, you have here a chart which is showing you the global resources used in building. Yeah, and you will see that one of the sectors which uses materials most intensively is actually this construction industry. Our buildings are made of materials of diverse origin and function, and whose extraction and transformation and disposal back into the environment at the end of the lifespan really accounts for a large part of the global environmental impact by our society. And you will see that the global pollution here you have on the back of the spreadsheet is given by the air qualities. That's the gas emissions of the city, and this is represent 24%. Okay. You have also the global warming gases. This is the greenhouse gases, the water, potable water, but also pollution is caused by landfill waste, which is coming from the waste of the construction industry. And this information, you got it from the Royal Institute of British Architects, who made a study throughout many years on the impact of the buildings. So we're talking about consumption of materials, and the building industry consumes around 25% of raw materials which are extracted from the lithosphere. And each square meter which is built represents of 2 tons of direct material, affecting between 6 to 7 tons of resources, being biotic or abiotic, and 20 tons of water if this is included in production. So if you're thinking a little bit about if you have an apartment or a house, each built square meter of your house is accountable for 2 tons of direct material that has been necessary in order to have that square meter of your house built. And if you think this is huge. Also, the construction industry is generating waste, like I said before, and the construction waste usually makes up around about 33% of the total amount generated by society. Usually we are accountable for 5.2 tons per person per year, and the domestic waste is up to 8.5%. That's 1.3 tons per year per person. On average, 60% of the construction waste is recycled, which is quite a high number compared to 20% of the domestic waste. Basically, we're not recycling our waste, but only on a very, very small portion. And here you have some indicators talking about the consumption of resources, and you have a presentation of extraction in billions of tons by different regions of the world. Okay, you have Africa, Latin America, Asia, Europe, North America, Australia, and Oceania. And also you have a chart on the right side, the consumption per capita, which is in tons. Okay. The global consumption of raw materials has doubled or more than doubled since the 1960s. And this is also due to the growth of population, but also to the economical boom. The demand has been constantly growing. And the difference in the level of consumption per capita between countries can be 3 or 4 times in proportion. That means different countries have different consumption per capita. Furthermore, rich countries import now, those days, most of the raw materials from poor countries, where a large part of the environmental impact is left behind. Poor countries do not really have policies in order to protect the environment, and there's also in need of money in order to make the economy grow. So environment is one of the last things that they're looking at. And now, because talking about resources and materials, I don't know if you know, but some few years ago it was this discussion that we will come to a point of no return, in the sense that we are using more resources from the lithosphere than in a natural way the lithosphere can regenerate. And here we have some indicators about the availability of resources. And maybe this chart has changed. This is a 10-year-old chart, and I'm sure it's not showing larger but lower numbers than we have in this presentation. As you can see, we have tin and zinc only for about 20 more years, nickel for maybe 40 more years, copper around 30 years, the iron ore probably for 120 years, lead 20 years, and the bauxite, it's close to 160 years. So the raw material reserves pose limitation to the use of materials and the quantities which can be used. And unfortunately, we're not aware about that, or we're not really conscious that each action that we're doing, or when we're buying construction materials, when we're building something, this has an impact on the lithosphere. The consumption of raw materials in terms of environmental balance should not exceed the rate of its natural renewal. That's what I was saying before. It seems that we have passed that point of no return, using more resources from the planet than it can naturally regenerate. And here, if you remember in the beginning, I said we're using 2 tons of material for 1 square meter of building construction. Here we're talking about something close to that, and it's called the ecological rucksack or backpack. That means it means the quantity of raw material needed in order to get the final product. And you see here different ratio for different type of materials. So for example, in order to have 1 gram of silver, you need 7,500 grams of raw material. This is 7.5 kilos. For the zinc, the ratio, it's 1 to 27. For iron, it's 1 to 14. For cement, 1 to 10. And the use of natural stone, it's 1 to 1.2, as opposed to petroleum, which is 1 to 0.1. And the ecological backpack represents the raw materials necessary to manufacture a certain amount of material or product. And I was giving the example of the mobile phones. A mobile phone who's weighing 150 grams can have an ecological backpack up to 75 kilograms. And 6 kilo computer can have something like 1.5 tons of raw materials in order to have it in our home. And again, you have here some other examples of the ecological backpack. The aluminum, it's 1:6. Steel is 1:15. And you'll see that in order to get 1 gram of gold, you will need 350,000 grams of raw materials to have it in place. And there's also associated with the use, the extraction of materials, of raw materials, in order to convert them in finished products or finished materials. There are used a number of technologies, but also a number of substances in order to put these things together. And this is providing a toxic environment. So we're poisoning, in a way, the lithosphere by extracting or producing final products. And this toxicity, the term of toxicity encompasses all harmful environmental effects generated through solid, liquid, and gaseous waste that enter the air, the water, and the ground. Each mining process is generating waste, but it also has a toxicity level at either the ground, the water, or the air. And what you have here, there's our labels that you can find in some of the products. And these labels are informing the ways in which nature and humans are affected by emissions resulting in the production of materials, construction, maintenance, and waste management. And these indicators are organic volatile components and some others are radioactivity, ionization, electric and electrostatic charge. And also by mining and manufacturing final product used in the construction industry, we are producing gases, carbon dioxide. And here we have also a chart which is showing approximately the approximate average of CO2 emissions between different sectors of economy. Okay, and you have 25% of the CO2 emission is coming from the building use phase. So during its entire life, a building is producing 25% of the CO2 emission throughout its life cycle. Okay, and you have 8% of the CO2 it's produced during the material production phases, and you have only a 3% of carbon dioxide emission during the building phases. So the erection phase of the building is producing the less CO2 emission throughout the life cycle, the entire life cycle of the building. Okay, and of course there are also other sectors that are, producing CO2 emission related to the construction industry in order to get a building standing up. So the CO2 emissions are global indicators, and they're very much present now in all the studies, and all the green rating tools are looking at these emissions, and also they are present in the energy performance certificates of the building. And usually they refer to the consumption of energy, the climate change, the cleanliness of the source, and the associated contamination. And there is no solution to the problem of climate change if there is no intervention in the building industry. This refers to the use of buildings as well as buildings materials. And yes, this is true. And the construction sector has a huge impact on the CO2 emission, but it's not the only sector. So this approach should be done in a global and harmonized way. I would think not only looking at the construction sector, but also this approach should be taken globally on other sectors which have a huge impact on the CO2 emission. And here we have some future tendencies regarding the energy and the CO2 emissions. And the idea of using sustainable materials is to use more and more material embodied energy, and we will talk about that to explain what that is. And the changes in regulation on energy and CO2 emission in the use of buildings derived from a directive which is called EU Energy Performance Buildings Directives to reduce them. And for now, there are not so many restrictions made in the material production phases. And furthermore, making buildings that are more energy efficient implies a higher consumption of materials those days. And the result is a reduction of the environmental impact at the scale of the building's life cycle, but has a larger repercussion on the material use. So the EPBD, it's called the EU Energy Performance Buildings Directive, is aiming to use, like you see here in the chart, more material embodied energy. So how do we look at the building? A building, it's put together, of course, using materials, but this is not only the materials are accountable for how to build a building or the extraction of the materials or the energy needed to provide these materials. It's also the philosophy and the concept on how we are building today. So what we need a holistic vision on this construction industry. And we need to look at materials and building systems, how design them, how put them together. We need to look also at the industrial system. We need to look also at the commercial system, how we are selling the buildings and what we're putting in the building. And of course, when we have the building ready, we need to have a smarter management of sustainable building. And that implies to touch several aspects of the industry. And the first one, it's a redesign of the materials that we're using in the construction industry. That meaning we need to minimize the quantities, really using what it's really necessary, to find solutions which have a low impact on the environment, and to try to use standardized way of building. That means dry and retrievable joints. And of course, to look at the end of the life cycle of the building, how can we recycle material, or how we can tap into renewable options. That would be if we're looking only on the materials, but also we need to look at the redesign of the whole industry. And the aim is to have zero waste, which is a very challenging and difficult task, in my opinion, to get. But also to have a recycling post-consumption, like I would say before, the use of renewable energy, and we have a lot of solution now. We have photovoltaic panels or wind energy that are producing less CO2 emission when they're producing energy, but also to look at an efficient transport of materials from the place where they're mined, extracted, to the plant where they're manufactured, to the place where they're being assembled or put together. And of course, another place we would need to look, it's a redesign of the commercial system. And we need that the commercial environment looks into a more quality towards the environment, and also transform products into services and use also natural capital with low maintenance cost, and of course promoting environmental efficiency. So the challenge of sustainability assumes that future generations should have the same resources available to them in equal in quality and quantity as the current model, the current generation. The current development model is not sustainable. The consumption of materials and generating waste causes multiple environmental impacts on energy consumption, toxic emissions, greenhouse effect, and so on. The building industry has a large impact on the extraction of materials as well as generating waste. So that's between a quarter and a third of the society's total. So what we do, we need to act, all of us. Acting on this is essential. And acting on this is finding ways of using a different model, a different development model for the construction industry. And if we're looking a bit back in the history, we can look at the 20th and 21st century industry models. And the 20th century model was an open materials cycle, meaning, extracting resources from the earth in a linear sequence, extracting, providing, manufacturing these materials, using them, and then they are becoming waste. And this is an open cycle. And the more that has been largely being used in the 20th century, and it's still used now, and the more we can find ways of closing this cycle, then we can look on towards an industrial ecology, which is inspired by the Great Biospheric Recycling machine, which is proposing a closed material cycles. And this is where the society of the 21st century is aiming to go, which means we're recycling, sending by manufacturing, and then using, and then again recycling. And this is the closed materials cycle. So again, going back and looking at the environmental impact of the buildings, we can see that 25% of this impact is coming from the extraction of materials, 33% is coming from the production of energy. It accounts for 20% of the water, and it generates 30% of waste at the end of the day. And you will see here on these pictures and percentages, these are data that have been compiled by different organizations which are showing these numbers. And the impact, not only that we're using those resources, but the impact of the building has some consequences. And this is the acidification of water and land, is depleting the ozone layer. It produces greenhouse effect. It produces land erosion. It can produce also acid rain. And also it's a release of heavy metals in the atmosphere and in our food. And you can name it. There's a lot of other impacts that are present today, like the smog being in the winter, in the summer, land occupancy, toxicity of the environment, or in the human body. So what are the to look a bit in a larger perspective, what are the inputs and the outputs of a building cycle? So we have a primary stage when we're using the resources, building materials. We can use renewable energy. We're doing that in those days, non-renewable energy, water and land. These are the minimum requirements in order to be able to start a construction process. And then using these materials with the energy, water and land, we're starting to put together things and to provide into a home. And the effect of this whole process is, like I said before, we have acidification, greenhouse effect, ozone depletion, photochemical oxidation, human toxicology, radiation, or noise. And we can find those in all the areas of the environment, in the soil, in the water, in the air, in the fauna, flora, or in the landscape. And the environmental quality of a building is the relationship between the living conditions and the resources consumed and the waste generated. So the quality of your living quarters is done by the resources that have been consumed and the waste that this has generated. And in order to be able to look in a sustainable way to the way of building, to the construction energy, we need to tap into this concept, which is called the life cycle of a building, the life cycle analysis. And this is a chart here which is showing a little bit this concept about the input and the output, what we are using in the input are resources, of course, and energy. And using those, we need a lot of other things connected to energy and resources. So we need to obtain materials and send them to industrial production, and then we have to distribute those materials and sell them, and then put them in use and operation. And then at the end of the life cycle, we have a waste, a final disposal. What do we do with this waste? We can recycle or we just can dump it. And at the end of the day, going throughout this whole life cycle, we have waste and emissions. Each stage of this journey, by obtaining the materials, the manufacture them, transporting them, put them in use, and transform them into waste, have effect on the environment. And this effect is coming from waste and emissions at the end of the day. And there are several ways of life cycle analysis. There are several cycles of materials. And you can see here there are 4 cycles of materials. And what we are using, the current model that we're using mostly is the cradle gate, which means that we're going and look for resources, we're mining them, we're making a first transport from the mining place to the place of manufacture, and then we have a second transport to the manufacturing facility. And then also a current model, it's at the manufacturing facility where another process is started, where another transport is used to deliver those materials to the construction industry, which is putting together the buildings, and then they're getting to their life cycle. This second cycle, it's called cradle to grave. Yeah. And cradle to grave, it's from mining, going through the whole process, and at the end of the life cycle, transforming the waste, transforming whatever is there in waste. A sustainable material, a sustainable life cycle of buildings or materials is to use these closed life cycle material, like I was saying before, and it's called cradle to cradle, which means that we're going from the initial process of taking resources, mining them, transporting, manufacture them, and then transporting them again, putting them into use. At the end of the life cycle, we are recycling the materials and not send them to waste. In order to compare the results of 2 or more life cycles, the objectives, definition, and environmental inventories, the phases that we're considering, the limits of the system, the functional units must be the same when we're doing life cycle analysis. And you will see further on how we can look at this kind of analysis of the life cycle of the material. So we need really to define the goal and the scope of the materials. It's also make an inventory, an analysis of the necessary materials that we are using, and not only materials, but also procedures, technique, and systems, and also to see what is the impact, to be able to make an assessment of the impact that all these things we're using have on the environment. And here we have the life cycle of a building, and we can see the impact to the environment of, if you're looking at the whole life cycle of a building. The phases, and it's split it on material production, on transport, construction, the use of a building, and we are using a 50-year window span. Maintenance, also during the 50 years of the existence of the building, and then we're looking at demolition or the waste management after the end of the life of a building. Of course, there are buildings who are still up after 100 years, but this is a standard life cycle of a building. And depending of which kind of building you're looking at, this is an average. Usually the residential sector is using a 60-year life cycle of a building. The office and industry is looking at a 35 to 50 years. If you look on commercial or industrial is looking at only a 15 years of life of a building. So this is an average that we're using here. So if you look during the material production section, the building is using 26% of the whole energy throughout the whole life cycle, and also is accountable for 38, close to 39% of CO2 emissions in the atmosphere, and it's also generating 74% of solid waste. And like I said, during the material production phase, the toxicity released in the air, in the soil, and in the water, it's quite high. Here is accountable for 75%. Now, if we're looking at transportation, you will see the impact on the entire life cycle of the building. It's quite low. Like we have 0.9% energy, maybe 1% CO2 emission, and the solid waste is irrelevant, and the toxicity is low. The same thing happens also during the construction phase. So the biggest indicators in the impact of the environment are not the transport of materials, neither the construction phase, which where you have 1.7% of energy used, 2.8% of gas emissions, 2.1% of solid waste, and also toxicity is quite low, 1.8%. The biggest impact on the environment is the use of the building. It's during those 50 years, and this is accountable, like I said, for 67% of the energy, total energy used, 51% of the gas emissions, and it accounts for 18.3% of toxicity during its whole lifetime. Also, looking at the lifetime of the building, you'll see that maintenance of the building has not a significant impact on the impact on the environment. You have only 2% of energy consumption, 3.3% gas emission, and also lower percentages in solid waste and toxicity. At the end of the life cycle of the building, like when we're deconstruction or demolishing a building, the waste management phase is accountable for 23, close to 23% of the solid waste generated by the sector. So the phases of material production, use, and at the end of the life cycle are where the most of the environmental impact occurs. The materials have a large repercussion in all of them. So where we really need to look in order to have a lower impact on the environment is during the materials production phase and also in the use of the building. And in order to be able to do that, it's to look on how we're using materials and what kind of materials are we using. And if we're talking about materials, we have two kinds of categories. There's the recyclable materials and the non-recyclable materials. And the non-recyclable materials that we're using, they're using the, like I showed you, the first life cycle. It's from cradle to grave. And these are non-recyclable materials. That means we're mining and manufacturing, we're using them, and we're dumping them. And this is 100% throughout the whole process. 100% mining, 100% use, 100% mining. And then we can tap into a different category, which is called infra-cyclable materials. And that means part of those materials can be recycled, or these materials can be recycled during a limited number of recycling cycles throughout their lifetime. That means we're doing the mining and manufacturing, we're using them, and then at the end of the using period, we're recycling them, and then we're using them again, and then recycling them, and until it reaches the end of their capability of recycling, and then we're dumping them. And then we have the third model, or the third category of materials, which are 100% recyclable. And that means we are mining and manufacturing and using also some recycling. We are using them, and after each use, they are recycled for an infinite number of time without those materials becoming a waste, without dumping them. And in this category, you can think of, if you think about materials that can be recycled indefinitely, that would be aluminum, that would be iron, which have a number unlimited of recycling capabilities. The environmental impact of materials is greater the further they are from the condition of recyclability or renewal. So if we're using materials that are not able to be recyclable, this will have a huge impact on the environment. And also, if we're using materials that are not able to renew itself in a natural way, like wood, for example. Thereby, non-recyclable materials carry all their impacts in one cycle, in one life cycle. The infra-recyclable materials have carrying this impact on a few cycles, and the recyclable are carrying the impact on an infinite cycle. And the repercussion of the impacts of infinite cycles and the disappearance of the phase of extraction and disposal make this option the most desirable one. Unfortunately, not all materials or not everything that we're using can be there. And I think we're not really prepared to look like that in our society. So now if we are talking about the impact that the materials have, we were talking before about the impact, the consumption of energy, water used, landfill, yeah. And here we have an example just to have an idea about how this impacts the environment. We're taking the ceramic tiles. Everybody is using ceramic tiles in their homes. And of course, after a few years, they're not, in line with the fashion. So we're dumping them and breaking them and putting some new. But a ceramic tile, during the phase of extraction and manufacturing, is using 2.76 megajoules per kilogram of material. And the environmental impact of energy represents the consumption of non-renewable raw materials and the contamination resulting from the transformation process. The embodied energy of the materials is one of the main indicators used in their environmental characterization, and we'll just want to talk about that. Also, some other impacts, we have the emissions of carbon dioxide. And we're keeping the same example, the ceramic tiles. During the phase of extraction and manufacturing, there's 0.22 kilograms of CO2 per kilogram of materials that are released into the atmosphere. And the environmental impact of CO2 emissions results from energy consumption and depends on the type of source that it used. It can be very high for fossil fuels and very low for renewable energy. So depending on what kind of energy we're using to manufacturing these tiles, this is having a lower or higher impact on the environment, considering what type of source we're using for the energy. And the CO2 associated with materials is one of the main indicators used in the environmental characterization of the materials. We're talking also about the solid waste, and keeping the example with the ceramic tiles. During the phase of extraction and manufacturing, solid waste is 2.11 kilograms of waste per kilogram of finished products, and as minerals, and we're using 5.3 kilograms of water per kilogram of finished product. So the environmental impact of solid waste represent the consumed raw materials that do not make up to the final product. So we're generating 2 kilograms of waste for a kilogram of finished product. Solid waste, or it's called MIPS, material intensity per unit of service. This is a unit that you might find in some studies, is an indicator that is rarely used in environmental characterization of materials. Also, a big impact on the environment is the toxicity. Again, with the ceramic tiles. During the phase of extraction and manufacturing of materials, we have 3.45 ECA, which accounts for toxic emissions released in the air. So 3.44 ECA kilograms emissions in the air for a kilogram of finished product. The environmental impact of toxicity represents the damage on biodiversity. And according to the indicator, it evaluates the effects on the environment, on the human beings, or both of them. Of course, there are other impacts on the environment, and we need to talk about them. And again, if we're taking the ceramic tiles, apart from the most important impacts on energy, on CO2, on solid waste and toxicity, extraction and manufacturing of materials are also causing water and earth acidification, ozone layer depletion, land erosion, eutrophication, acid rain, heavy metals pollution, land occupancy, and many, many more. So what is the place and the scale? So here you can see the impact of the materials. Yeah. The environmental impact of a specific material, it's closely linked to the rest of the building materials, which in turn form an important part of impacts throughout a building's life cycle. So what are the conclusions of this short approach overview, if you want, is that the open material cycles, the extraction of resources, generating waste, are the causes of the environmental impacts of building products. These impacts arise from the extraction of raw materials, industrial processes of transformation, manufacturing, transportation, building maintenance, and the disposal at the end of its lifespan. There are materials that are managed in an open cycle whose impacts can be smaller because they contain some environmental improvements. They are a palliative but not a solution. The underlying problem remains. And now, if we've been through the open material cycle, let's go and have a look on the closed material cycle and see what's the difference and what impact it has on the environment, if any. Like we were saying, the dominant production model for the 20th century was extracting, manufacturing, use waste. And what we're looking now in the 21st century and we're going towards towards industrial ecology inspired by the Great Biospheric Recycling Machine which is proposing recycling, manufacturing, use, and recycling. So we're looking at some strategies in order to reduce impact on the environment in the construction energy. And you have here 5 steps which are important and milestones in this respect. And this is the reduction demand. So it's important to look how much we need if we really need. And for that, we need to optimize the material use and reduce the quantities per unit of service. Also, when we're looking at the material, we need to find or try to increase the efficiency. And for that, we need to select materials with the same characteristics, but lower impact on the environment. And for that, we need also to look locally and use local resources and building by using or reusing local materials closer to the construction site, not to bring materials from hundreds of or 1,000 kilometers away. And of course, a big topic which is open today and very hot is the recycling or the renewal of the materials, and use recycled, that's industrial materials, or renewable, which are natural materials. That would help a lot to reduce significantly the impact on the environment. And also we need to look at the impact neutralization or compensation. And this is by choosing products that compensate their own impacts, or which are called carbon neutral. So these would be the 5 strategies that we can look at in order to have a lower impact on the environment. And again, how much material does a building consume? And like we said in the beginning, it does a lot. Only on site, it consumes 2.5 tons per square meter built, which in reality, it's 7.5 tons, since producing a kilogram of materials implies also generating an additional 2 kilograms of waste, including various associated environmental impacts. However, by avoiding unnecessary consumption and by optimizing the use of materials and recycling, it is possible to save on both materials and their related impacts. And here we have one, in my opinion, one of the best examples, the demand of reduction. And here you have the example of an iron bar, which, if used in different geometries, will keep the same strength, but will use only a percentage of the necessary materials to put in construction. And this is an optimization of using a kind of material. So if we're looking at your first example, it's a square bar of iron, which has 5 by 5 centimeters. And the bearing capacity for that bar is 1,750 kilograms. If we're transforming that bar with the same amount of material in a square tube, then you will see that the load bearing capacity goes to 5,360 kilos. And moreover, if we're using the same quantity of materials in a cylindrical tube, then you'll see that the load bearing capacity goes to 7,000 kilos. Furthermore, if we're using different kind of geometry with the same amount of steel, you will see for an I-shaped bar, the load bearing capacity goes to 5,000 kilos. Then if you use an X, it's a 6,400, a Y, it's 10,600. But not only that, if we're using different combination of these geometries, we can increase the strength, the load bearing capacity, using only a tiny fraction of the material. And you have here these examples. If we're applying a pressure of 10 ton of this kind of bar, the use of material is 0.15 cubic meter. Then if we're using a different geometry, it goes half down. And if we're using, again, different kinds of geometries, the use of material, it's really, really a fraction of what it was in the beginning. Yeah. So steel pillars with the same amount of materials and the same length, but with a large difference in their bearing capacity, which comes from different geometry. Yeah. And also steel beams with the same span and the same bearing capacity, but with a difference in the use of the material. So the material optimization can really be something we should look at and find ways of how to optimize the use of material. In this case, is increasing structural capacities. We're looking at steel bars. Another place where we can look, and this is very important for those who are involved in the construction industry, is to look at the inception of the building. And the inception of the building is the designer. The architect is the solution that the designer is providing of how the building is oriented, where it's sitting on the land, what type of material is using, and in which way it's taking advantage of the natural geometry, geography of the place where is built, developed. And here you have a very simple example of two buildings which are using two different ways of using the underground parking. And it's by reinterpretation, of the vision or the building codes in order to build the building. In the first case, you have an underground parking on one level, so that means excavation, pouring concrete, putting additional ventilation system, exhaust, putting additional fire safety system in case of a fire. And in the second image, you have an open underground parking where you don't need so much concrete to put around the building for the walls. You don't need evacuation system, and you don't need complicated extinction system, because it's an open place. There's no retaining walls, floor slabs in contact with the ground. So the reinterpretation of building codes and space allocation can reduce the quantity of resources needed to build an underground garage. And here you have the example of the excavation and retaining walls. And this can result in additional benefits, such as, in this case, natural ventilation and lighting, but not also that, but also economy in concrete, steel, equipment, which leads to financial economies. Another way to look at, increasing the efficiency is how we're looking at what kind of material we're putting into use. And here you have the example of two thermally equivalent facades with different environmental impacts. Yeah. And in the first, on the left side, you have a concrete walls, reinforced concrete walls with a layer of mineral wool insulation. And in the second one, you have a brick wall with mineral insulation wall out at the outside and gypsum board at the inside. And as you can see, the impact on the CO2 emission, it's quite significant. It's 30% less in the second case by using bricks. It's only 65 kilograms of carbon dioxide on the square meter compared to close to 95. So the understanding, the vision of the designer and the knowledge, of course, of the designer can, from the beginning of the development of a building, can have a significant impact or lower impact, significantly lower impact on the environment. And I think this is a must to have architects with that kind of vision. And of course, we're looking at the, increasing efficiency when we're building. And in this case, you have the example of two buildings. One is being built by cross-laminated timber structure, and the other one, an open concrete structure with beams and pillars and floor slabs. And the comparison at the environmental comparison is that to have the same structural strength, we need to use 60% more timber, and that has an impact on the cost. But the advantage is we have 300% less weight, we're using 170% less energy, and we're having 220% less emissions. So this is just an example to show how it works. Also, I was saying that we need to look at how we are using our local resources in order to use the available materials on site rather than bringing them from far away, hundreds of or thousands kilometers away, or paying for expensive materials. And in this case, we can use the local resources, which can be wood, which can be stone, or even earth. And here you have an example of old buildings with, refurbished with reused materials on the left side, and on the right side you have an earth construction of a building. Still on the using the local resources, you have here an example, the Museum of Science, Climate and Environment in Spain. They have been using the stones the project involves the reuse of earth and stone materials from the excavation of this site. So they are used in development of the building landscaping and the adjacent park. Thereby, the consumption of new materials and their transportation to the site is avoided. So they used the existence of local materials to do the landscaping and create something that did not need to bring additional resources or and materials to do that. Recycling and or renewal. And this is important. Recycling, we are talking about recycling. We are talking about recycling when we're using industrial materials, such as iron, for example. And here you have how we look at iron. So we're using raw materials, iron ore, limestone, coal, which are going through a process of preparation, to the sinter plants, to the coke ovens, and then they're going to the iron making using an integrated steel making, with a blast furnace or a basic oxygen furnace. Of course, in this process, we can add scrap metal, which helps the production. And if we're using the current model, extracting materials and doing the manufacturing, we have a so-called BOF, which is basic oxygen and electric furnace, of 38 megajoules by kilograms. But if we're using also scrap metal, which is have been already used before, we can drop down this oxygen and electric furnace, as you can see, by steel energy by 50% and the building energy by 10%. We're using only, 50% of the materials. So how can we recycle materials? How can we look at recycling materials? I was telling you before that there are two kinds of recyclable materials, the infra-recyclable and the 100% recyclable materials. And here you have an example of two of these materials, the infra-recycling material, which is concrete, and we can use concrete and transform it into aggregate for blocks instead of using natural stone. And you can use approximately, I think, 30 to 40% of concrete, crushed concrete, instead of stone, to mix with the cement and have a concrete. And an example of 100% recyclable material, I was saying, this is aluminum, which can be transformed into new aluminum for frames by recycling. And we're talking, of course, about impact neutralization or compensation. So how can we compensate or neutralize the CO2 emissions is by using biofuel, photovoltaic panels, or wind energy. In this way, we can offset carbon emissions. And here we have also talking about neutralization and compensation. This presentation is talking about a carpet, which is neutral climate carpet, which is coming from a recycling process. It's called cool carpet. So what are the actions to minimize the material impact? And I was saying that we need to decrease the demand, and we can decrease the demand by design of a building that decreases the materials demand. And going back to the design, to the architects and the designers, structural designers, equipment designers, they are the gate towards this lower impact on the environment. design of a building that decreases the generation of waste. And for that, a designer can think about designing a building with right joints that can be deconstructed instead of being dismantled or demolished and reused in a different places or ways. Design of a building that can be deconstructed, reused, and recycled. I was just talking about that. Have an efficient user manual of the building. And this is such an important thing because during the lifetime period, the usage of the building, we need to maintain, to operate and maintain the building. If we are able to
Alo? Cătălin?
I think somebody's talking over. If we are using an efficient manual in order to operate the building, then we can really reduce the consumption and energy and the emission of CO2 emissions. And of course, we need a training plan for those responsible for maintenance. It really makes sense to know how and where to provide maintenance in a building and at which rate, which cycle, in order to have the building really being operated efficiently. Another place to minimize the material impact is increasing the efficiency of the construction system. And then we might look at the excavation and foundation, at the horizontal and vertical structures, the facades and the dividing walls, the roofs, the insulation of the roof of the building, how to use the windows and the solar protection, also the horizontal and vertical interior partition, the flooring and the paneling, the thermal and acoustic insulation, the waterproofing, the paints and the varnishes, and of course the HVAC system, which is a very important part of the building. Another place where we can use the advantage of, it's taking advantage of the local resources. I think somebody has the microphone open and it's talking over.
La ce oră? Sau mâine până, da, și vreau să văd cum fac.
Is there anybody who can mute the microphones?
Da, da. Păi mâine e recepția. Mâine la ce oră ești? Adică mâine. Am înțeles. Hai că și o să fiu la partner mâine.
Okay, thank you. So we're looking at taking advantage of the local resources, and that means using the ground, using the rock and gravel, and also taking advantage of pre-existing construction. That can help a lot, like I was saying before. And also, of course, recycling and reuse materials, the recycling materials and the reuse of materials. And of course, compensating of the generated impact. So balance of resources tending towards zero, and the materials that neutralize impacts, and study of minimization and waste management, plan of waste minimization and management also during the construction phase. Yeah, I think we're gonna make a short break for 10 minutes, and maybe we can find a way to close those microphones because it's really bothering. It's difficult for me to talk when I'm being talked over. So I propose to have a 10 minutes break, and we'll be coming back at 11:45. Okay?
Recepția este joi la ora 10. Nu, mâine nu e joi. Mâine e miercuri. S-a rămas.
Okay, I'll be seeing you in a short time. Okay, so we are back. I'm not sure if you can hear me. Good, excellent. So we were talking about the actions to minimize the material impact. And just show you the 5 strategies. And we're talking also about how to use lower carbon construction system. And here there are some example by, using timber, wood, CO2 absorption during the growth of the wood. So this is the kind of renewable materials that we can use in the construction. Or we can use industrially manufactured structure, which already prefabricated, brought to the site. We have a lighter structure or using recycled or renewable materials instead of building on-site elements or joints. We can have them prefabricated and transported to site and just assembled. Also, using double functioning walls, structure and envelope, and using recycled or renewable materials can help in this respect. And of course, we are talking about recycled steel construction systems made entirely of retrievable materials. Like I said, not to demolish, but to dismantle or the joints, the systems that can be either being assembled in a different geometry or in different place or given a different purpose. And by using this kind of approach, we can lower the emissions of carbon dioxide throughout the year up to 300 kilograms per square meter, as you can see here. So in order to close the chapter and drawing some conclusions is the fact that closing the material cycle is the answer to the demand of physical and environmental sustainability. So this is the way we need to look at things, to tap into those 5 strategies and create a model of closed material cycle. Doing this within the limits of the carrying capacity of the planet is the sufficiency condition. So, and we need to be able to see at the natural model that the Earth is giving us, not to use more than the Earth is able to renew. In the building industry, the key to closing the material cycle isn't found in specific materials, in a construction system or a type of a building, but in the management of the resources in the life cycle. So the way we're managing the life cycle of a building, then that gives us really the key to close the material cycle and also the key to sustainability. And depending on the scale of the intervention, the systems that need to be managed can be buildings, can be neighborhood, can be cities or territories. The wider the vision is, the more efficient the solutions will be. If we will have an integrated system at a larger scale, then impact will be at a larger scale. It's a more macro management than micro management. So now we will go into a different section, which might be of interest for you or might be not, and we will look in the rating tools. And I'm sure you know about those rating tools, most common in building and construction industry. We're talking about the green labels that we can obtain based on an assessment done by a third party, which gives us the image, the sustainability image of a building. But there are also other rating tools. We will go briefly through them. So, and we will start from materials. So, what are the requirements for the sustainable materials? So, we need to look at the checklist, and then the first things to look at is to have a low primary energy and low primary emissions. That means natural production, and that means recycled materials. Another criteria would be that the material should be non-polluting, without organic volatile components, without emission of radiation, gases, etc. Materials that are not hazardous to health, which have low or, if possible, zero toxicity. And of course, another criteria was, and I mentioned that several times, it's separable and recyclable waste, simple and non-composite materials. And here in this picture, you have an example of wood particle boards, which are assembled without formaldehyde. Formaldehyde is highly extensively used to produce wood particle boards. Another criteria is to look at the product when we buy the product, if it comes with environmental certification. And this is the Eco Label 1 to 3. If we can use materials with removable joints that can be dismantled, that can be dry assembled, or that can be deconstructed. Also looking at materials which are made with recycled materials and have residue and can be a residue as a raw materials for other materials to be recycled. And of course, materials or joints or systems that can be reusable, have a long lifespan, can be modular. Yeah. Also, another criteria for the materials is to be durable, low maintenance, and without conservation treatment. For example, here in the picture, you have a galvanized steel mesh, which does not need any maintenance if the galvanization is done correctly. It's a deep galvanized mesh, which has unlimited lifetime and does not need maintenance. Yeah. Also use non-recyclable waste to extend the lifespan of the material. Another criteria is to save energy when producing and using the materials through inertia or thermal insulation, and of course saving water. And we can do that by collecting rainwater and reuse rainwater in different ways with the help of different systems for toilets, gray water, or for soil, percolating the water in the soil, irrigation, or maybe other things. And now, talking about labels, just briefly mention them. Some labels you can find on the products are type 1, 2, or 3. And you have here some example of labels and what are the criteria which those labels are addressing. The type 1 is environmental labeling, type 2 is a self-declaration claims, and type 3 is environmental declaration. So the metrics or these criteria, these labels are looking at, you have defined them here in the table. So type 1 is a multiple criteria, type 2 is a single criteria, and type 3 is a multiple criteria also. And you see that type 1 and type 3 are taking into consideration life cycle. Yeah. And also type 1 and type 3 have third-party verification certification. Type 2, it's more self-declaration certification claim. You have here another example. This is the UE Type 1 Eco Label. And when developing UE Eco Label criteria for products, the focus is on the stages where the product has the highest environmental impact. And this can differ from one product to the other. If we're looking at textile, for example, fabrics have strong environmental impact when they are dyed, printed, and bleached. For this reason, experts have come up with the criteria for textiles in order to make sure that harm at the manufacturing stage is reduced as much as possible. Okay. And for each individual material, environmental requirements can be determined that ensure low environmental impact during manufacturing, but also throughout its life cycle. And establishing these requirements cannot be done automatically. Its application depends on the function of each material in the construction system and how it is managed. The eco labels are guaranteeing a certain environmental characteristic of a material through an evaluation and certification system conducted by a third party. But an eco label does not give you everything. It certainly helps, but we need to do more than only buying products with an eco label. What would be the first steps? And what to do? It's the initial characterization of the materials, and we need to look at the origin and the type of raw materials, the manufacturing process that it's used, the differences with respect to the alternative. So what alternative can we use for this kind of material or product? Also, another place to look at is how can we define an equivalent functional unit? That means is determining the surface area, the building envelope, etc., with defined performance characteristic. What do we want to achieve, in other words? Okay. And then do an evaluation through multiple impacts. What impact does that have on the energy, on the CO2 emissions, on the solid waste, the toxicity, and the exhausting of non-renewable resources? And coming back again to the whole philosophy, the holistic approach is have a vision of the complete life cycle of the materials. And for that, we need the examination of the different phases, the manufacturing, the transport, the construction, and the end of the lifespan. And of course, the interaction between all these materials. And here we have, and I think this is the simplest study case, the example of a modular curtain wall. And this is coming from the Technical University of Catalonia from Spain, where they wanted to change the curtain wall of a building in order to have better energy performance. And you will see what they have done, what solutions they have done by assessing different materials and different ways of putting these materials together in order to have a better energy efficiency. So this was a modular curtain wall, and this was the section, the elements of which it was being manufactured. It was called the FB7220. Okay. You have, okay. And for that, they made some considerations. They made the facade analysis from the environmental point of view. Okay, so they looked at energy, CO2 emission, waste, toxicity, but on the material composition and also at the thermal performance and the lighting scheme of the facade. And the question was, how should the facade be composed? How should a curtain wall facade be composed? And starting from that place, they made a comparison framework. They said they looked into 4 directions. Okay, they had a developed wall and the reference wall in order to be able to assess the new proposed solutions. And the FB new curtain wall against a conventional curtain wall, and also against a traditional facade. Okay, this is the reference here, and this is the new developed, and this is the also new developed, and the impact that had on the HVAC and the lighting system, and also the impact that it had on the materials. So they have considered a few scenarios. So this is the new curtain wall. They have a horizontal section, and then you have a masonry facade with the existing curtain wall and the traditional facade. So the strategies that have been used were to reducing the proportion of aluminum used and using recycled aluminum. Another one was integrating renewable or recycled materials into the substructure. Then integrating renewable or recycled materials into the opaque panels. And of course, maximize the potential to separate, reuse, or recycle the materials. Yeah. And they have been looking at the impact of the traditional materials. And as you can see, the biggest impact in energy content is aluminum. Then we have silicon, PVC, XPS, the copper, stainless steel, glass fiber, etc. So the majority of materials used in a curtain wall have a high embodied energy. Their use should be limited, or they should be substituted by other materials that have a lower impact. And the alternative considered for material substitution was to use 100% recycled aluminum, plywood of local origin, various recycled plastics, wood polyethylene composite, or concrete with fiberglass. Also, they were looking at recycled and pressed carpets, natural plaster, chipboard with recycling wood, natural ship wool, and recycled textile fibers. And after doing the analysis on each type of material, we have here an analysis of 4 types of mix of elements and composites to build this facade. And we have the structure, the opaque enclosure, and the transparent enclosures. And for each one, we have the 4 types of elements that have been used. You have A, B, C, and D. And you'll see that in type A, they've been using aluminum in structure, timber, steel, EPDM. And then on the enclosure was wood board, ship wool, craft paper, again, exterior insulation, aluminum, fittings and fastener steel, and ceiling and joints. The transparent enclosures, it's double norm, that's double glasses with sun control and with a metal framing of the glasses. And you see that type B, the biggest changes, for example, type B is using PVC instead of timber. Type C is using a plastic, and type D it's using a concrete of the reinforcement for the primary profiles. And again, other differences can be seen at the opaque enclosures, where we have plasterboard instead of wood boards. We have fibers, recycled fibers instead of ship wool, and also most of them are using craft paper. Okay, so the glass panel, it's the same for the whole 4 types of facade design. And here, this chart is showing the environmental data for materials, the composition and the quantities, the source and the origin, the impact on the environment, and here you have aluminum and lacquered aluminum, and you will see the difference on energy. For example, in aluminum, you have 154 megajoules per kilogram, and if we're applying a lac on the aluminum, the energy goes to 211, as of course the CO2 emissions are 3 times more than regular aluminum. So they have built a data sheet for each material, studying, source, origin, and the impact on the environment. Okay, and here you have the FB720 Type A. We just seen it before. They have made an assessment for the weight and also an assessment for the energy. And here you can see on the weight, the biggest impact is one butyral, 12%, laminated wood, also solar glass, and also here the energy impact on this facade, you'll see for each one. And after doing the analysis on the 4 types of the facade, they came up with these results, which are quite interesting looking at them. As you can see, the facade 720A, okay, so the assessment has been made during the manufacture, during the construction, during the maintenance, the dismantling, and a total of points for each type of them. So manufacture, here we have kilos on square meters waste from the manufacture of basic materials. Construction, it's waste from packaging and surplus construction material. Number, maintenance is non-recyclable waste due to partial replacement of the wall at 35 years. Yeah. And the dismantling is non-recyclable waste due to dismantling or demolition of the wall at 50 years, which is the end of the life cycle of the building. And the charts provide a clearer idea of the impact of each phase on the total waste in each case, as well as a relative comparison between the various facade systems. The lowest values with a variation up to 40% due mainly to the manufacturer phase corresponds to the different versions of the FB720 facade. So as you can see, the A version has the best scoring compared to the masonry here, masonry facade, and the traditional facade, which are here on the bottom. All 4 versions of the new facade are better than the masonry and the traditional one. So now, again, a comparison between the 4 types of facade, the masonry and the traditional facade. The masonry type of envelope is an intermediate position with double the impact of the 720 facade that generates the most waste. The highest level of impact was caused by the traditional facade with 4 times the average impact of the 720 facade and 50% greater than the masonry. And you have them here. This is the solid waste throughout the whole life cycle phases. And these are the 720 facade, the different versions of the 720, that's the masonry and the traditional facade. So an additional impact reduction for the 720A type, it's combined positive impacts on the various possible improvements. So and some the improvements that have been made here was by replacement of aluminum frames with wood, and that saves 65 megajoules per square meters, and that's a close to 3% saving. Another one was facade workshop close to the building site at no more than 75 kilometers instead of bringing them from a longer distance. Reusable packaging and recyclable materials. Where the most impact has the useful life of the joint extended to 50 years. And also using glass panels that can be totally dismantled. And you can see by these additional measures, they gain another close to 35% of savings on energy. And the impact of the proposal to improve the life cycle, the table shows the combined positive impacts of the different additional proposals to improve environmental performance in absolute and relative terms, taking into account the total energy consumption throughout the entire life cycle. Yeah. And by doing this exercise, they came to the conclusion that in the phase prior to making design decision, technical factors are crucial to the control of environmental impacts and do not depend directly on the materials that are used. The materials selection and optimization, the geometric definition, the determination of joints, and the management of the material resources up to the end of their life cycle are the main keys to reducing impacts. Although the degree of difficulty in implementing the various proposed additional measures can vary, there are sufficient opportunities to make improvements that have a positive impact. And the question is, how do we look at the development of a building? What are the main elements that we're taking into consideration? How can we change our vision of or our understanding about the impact that the choosing of materials, of techniques, design, quantities can have an impact, or lower or a higher impact on the development on the building? And this is the invitation for each one of us, even when we're looking at our home or, considering larger project, especially for those who are working in the territories or cities and looking at urban development plan. How can we make our cities look better, feel better, and have a lower impact on the environment? So we were talking about certification tools, and you probably know that now for many years, there are a number of green certification tools for building, which are assessing a number of parameters from the design phase until the end of the life cycle of the building, some of them in order to give an impression about the how sustainable is the building. And we have different types, different levels of certification. And you have here on the level 1, the most known certification level, which are applying specifically to buildings. And we have the LEED, the BREEAM, the DGNB, HQE. So these are applied to the building because they're doing a multi-impact analysis throughout the whole life cycle of the building. Then we have a different type of certification tools like the EU Eco Label, which has a multi-impact analysis, but it analyzes only one life cycle aspect. And then we have level 3, which does one impact analysis on one life cycle. And then we have the level 4. And in this category, this is the energy performance certificate, which is part of one impact analysis over one life cycle phase. And of course, we have the environmental product declaration, the EPD, which talks about the product category rules, doing a life cycle assessment. Then we have this EPD, which is going to a third-party verification. But what is really something to look at is the main certification systems that are present and used in the construction industry. And the most well-known are the LEED certification tool, which is developed by a US Green Building Council in the United States, or the BREEAM, which has been developed in UK. We have also the DGNB, which is developed in Germany. We have the HQE developed in France, and Verde developed by Spain. So these are the main ones used throughout the world. Some of them are applicable only locally. Some of them have a wider range of application geographically, but also in the specific sectors of the building industry. And these are two types of building certifications. We have the first generation and the second generation. And the first generation is a checklist format. The second generation one is a summarized format. The first generation is looking at the project is evaluated by contrasting it to criteria of good practices. It has global points or eco points, which are awarded that summarize different impacts. The evaluation of specific impacts is not apparent to the user, and the system does not provide quantified data of the environmental impact. The rating is done by scoring points, and occasionally there are references. The second generation of these tools is also a project. The project is evaluated through modeling its performance, which is different from the first generation. It has impact indicators that are used with the objective magnitudes, and the evaluation of specific impacts is apparent to the user. So the user can see what impact has a specific evaluation. And the system does provide quantified data of the environmental impact, and the rating is done by comparing impacts to a reference and through a point system. We have here also points. And here we have the LEED. It's one of the most known certification tool. It has been brought to the market in 2000, and it's doing an evaluation of the quality, and it gives you looking at the impact categories such as site, water, energy and atmosphere, materials and resources, and it can be applied to the phases of design, of construction, renovation, and management. This is a type 1 generation, and it's a checklist of criteria and does not provide impact on values. It can be used on residential, on tertiary, on interiors, distribution hub, neighborhoods, on new buildings or renovation. And it's doing a qualitative evaluation of materials without quantities, and the impact on the total value, it's about 13%. So the criteria is looking at is the waste management, the reuse of materials, the recycled content, the regional origin, and the quickly renewable impact, and the certified wood. And here, this is the criteria, and you have here the performance of what they're looking at. At the waste management, they're looking at the separation of the elements and the delivery to recycles. Reuse of materials is possible reuse of structural and envelope components. Recycled content materials that impact the budget. Regional origin is looking at factories at a distance to the site no farther than 800 kilometers. Quickly renewable, they're looking at wood and plant fibers in general, and they're looking especially at wood certification, FSC, and others. DGNB DGNB is a German tool, and it's being brought to market in 2008. It's the category of impact: site, water, energy, materials, design, regional priorities. The phases it can be implemented, it's in design, construction, renovation, and management. This is a second generation tool. It provides a quantitative evaluation of criteria and includes the impact values. Then it can be used in residential, neighborhoods, new buildings, and renovation. And you have here the criteria, the impacts on energy, the carbon dioxide, the life cycle, the waste reduction, the maintenance, and the construction efficiency. So the performance is measured on low impact products. The more low impact products you have in energy, toxicity, and emission of carbon dioxide, they're looking at the building cost during the entire life cycle and the value stability. They're looking at the separation of the elements at the end of the life cycle also, and they're looking for simple maintenance and easy cleaning. And of course, an important element is the efficiency of the constructive system, net area on built area. This is a factor, a percentage that most of the developers are looking at. What is the percentage of net area compared to the built area? And usually in residential building, this percentage is around 60 to 70% in best cases. In office buildings, you are around 80, 85 buildings, an efficient building. And in industrial and logistic, you can go up to 90 to 95% net area or usable area compared to the built area. The HQE certification is a French tool. Like I was saying, it has been brought to market in 2003. It's a self-evaluation tool, but it's not for certification. But there are self-assessment tools available. It has impact categories in construction, site, water, energy, like all the others, and also can be used in different phases like design, construction, renovation, in-use stages and management. This is also a second generation certification, and it can be used in homes, non-residential, new existing buildings, and also renovation. The criteria, you can see here the impacts of products on building, the waste, the local production, the biosourced product, certified wood and recyclability. So the impact of products and building, it favors the low impact products. That means a lower energy emission of carbon dioxide and toxicity, and use of certified products, consideration of impacts and EPDs from 50% to 100% products on global building impact and calculation of the assessment. They're looking also of the waste management. They're looking also to optimize transport of renewable materials, and also looking at the minimum quantity of biosourced materials. Looking also on the wood certification, integration of a specific minimum volume of wood and implement materials and products enabling carbon dioxide to be trapped. Recyclability, it's also the removability and the separability of the construction products and processes with the view to optimal environmental management of their end of life. Verde is a Spanish tool. It's a self-evaluation tool. It has pretty much the same impact categories like the others, and also it can be used in different phases like design, construction, renovation, and management. Is a second generation tool, and it can be used in residential, in offices, in new buildings, and renovation. And it focuses on low impact of products, separation of the elements to be sent to recyclers, factories at distance to site not farther than 800 kilometers, and possible reuse of structural and envelope components, and also looking at standardized element with removable joints, and also is focusing on large volumes with removable joints. So these are the okay, BREEAM. I went over BREEAM, which also an important certification tool. It has been to the market in 1992. This is one of the oldest tools present on the market, which has evolved during time, and now it's geographically adaptable, and also it has various areas of expertise, like in residential, commercial, existing buildings, neighborhood. This is a first generation tool, and also it can be used in different phases on design, construction, renovation, and management. So BREEAM is encouraging low environmental impact materials such as renewable ones. It's very focused on that. It's also looking in the reuse of the facade. Its reuse of reclaimed materials is not very common. So that's interesting to see. Possible reutilization of structural recovered elements. This is also something that is not very common. And also looking at responsible materials like labeled materials such as certified wood with FSC. Renewable materials are encouraged with the low impact insulation. And also a place where it looks is the high durability and low maintenance on design and materials. Oh, this is a qualitative evaluation of materials without criteria. Oh, these are the tools, the certification tools for buildings, and depending on the preference of the developer or the user, they might use one or another certification tool, and each one has different scoring points, which gives you the impact or the reduced impact of the building according to the certification, the points that we get. And if I remember well, BREEAM has good, very good, excellent, and outstanding criteria or certification labels, and LEED has silver, well, regular, silver, gold, and platinum. These are the labels that you get, that the building can get after a certification based on the assessment made with these tools. So the EPD describes the main environmental impacts of a product in a standardized way, but do not guarantee that this impact is low. So we can show you the numbers, but that doesn't mean this would be low. The evaluation system and environmental certification of buildings analyze the life cycle of the building in a simplified way, and multiple effects of the various phases are evaluated, and an overall rating is provided. The second generation systems quantify environmental impacts in conventional units of measurement. Compared to a conventional system, they also inform about impacts that are avoided. So the idea is, like I was probably saying in the beginning, is that the developers, the designers, the manufacturers, the builders, the managers, and the public administration, through their often disjointed actions and decisions, demand resources and generate waste. And this discussion, it's needed to be done in a different way, like bringing all these parties together at the same table and try to find a common language and a common direction, which can optimize also the need of the developer, which is mostly profit, but also the designers who are looking for new solutions, also for manufacturers to find new ways of executing the materials, and also the builders to put together these materials. And of course, the public administration has an extremely important role in this discussion. Is how do we want to see our cities now and in the future? What would be an efficient city, an efficient environment for the people who are living in those cities, in those communities, and how this will impact the environment. And usually, this is a difficult conversation, but it can be done if we're bringing everybody at the table and you know, laying down the needs which are present in the society and on each sector. And in this discussion, of course, the urban planner has an extremely important role, and we're looking at preserving the territory, reducing mobility, and freezing the growth of the urban footprint. You know, not taking more land than is necessary to develop a building. Also, for the developer, it's trying to find alternatives that respond to the unmet housing without increasing building stock and consuming natural areas. For the designer, it's a must to design processes capable of drastically reducing the consumption of energy, of water and materials, as well as the generation of waste. For the manufacturers of materials is to offer products that close the material cycle, so we can use renewable or recyclable materials. For the builders and other technicians, we need a structure and the training tailored for the renovation of the building stock. Renovation of the building stock would be a place where to look if it's possible, instead of developing new buildings using new stock of materials. And the public administration is to take actions for removing barriers and creating incentives for the implementation of the renovation sector. Create the market for green retrofitting. I don't know if you are aware about that, but for example, ROGBC, Romanian Green Building Council, has implemented in various cities of Romania a rating tool, which was providing for new developments or existing developments a certification showing that by taking some measures, these buildings can lower impact on the environment. And based on those tools, some municipalities were offering 50% to 100% discount on the taxes for the buildings that were to be developed or were already being developed on the land, which for big buildings, it's a huge cost saving. And they were doing that for a period of 3 or 5 years when a new assessment was needed. So, and people start to develop in a more responsible way buildings, in a more responsible way, looking at the impact of the environment, considering that there was this incentive at the end of the day paying lower taxes. Of course, it's important also to look at the user and the building manager. Management and control strategies to reduce energy consumption, water impacts of maintenance material, and generation of the household waste. So this was basically the discussion about the certification tool. We will be looking now in this second part. Hopefully we'll have enough time. Yes, we do. We will be looking at the closing the material cycle, looking at nature-based materials and industrial-based materials. So I don't know if there are any questions until now, but if they are, Elena, you can send them to me. If not, I will keep going on. Okay, beautiful. Thank you so much. I hope everybody's still awake here. So, talking about the standard production model, we were saying that this is a problem, and we just addressed that in the beginning. The manufacturing of almost all industrialized products, including the most innovative one, it follows a sophisticated linear production system based on the same sequence: extraction, manufacturing, and waste. And from an environmental point of view, this model still has the same negative characteristics since its creation during the first industrial revolution. So this model is inherited from the industrial revolution, and we have kept it going until now. And the standard production cycle is a problem. The production starts by extracting resources from the lithosphere, transforming them into industrial raw materials, and as a result, resources are exhausted and waste is generated. The raw materials are transformed into products using energy and generating solid, liquid, or gaseous waste. The product at the end of its lifespan will also be disposed as a waste and thus contaminate the biosphere. Yeah. And by contaminating the biosphere, it's also contaminating the quality of our lives. Another production model can be the solution. And this new production model needs to look at the closing of the material cycle and the reconversion of the waste back into the resources. And this must be included in our industrial model to face the challenge of sustainability. In order to do so, renewable material can be used by letting nature to do the recycling, or the materials can be recycled industrially. In both cases, the future strategies lie in finding which is the most adequate option case by case. And the new production cycle is a solution because it highlights of sustainable enterprises such as zero waste, non-contamination, emissions, renewable energy, closing the loop. We have using efficient transportation, involving all the parties to participate at this cycle, and redefining economical values. And there are two ways to close the materials cycle. The first one is to use the biosphere as the great machine, able of gathering waste and turning it into resources by means of its own natural process. Then this is the path of the renewable energy. The second path is to follow the technical system by organizing adequate waste management, designing the recycling processes, and turning the waste again into resources. And this is the path of the non-renewable materials, is the path of recyclable materials. And there are no good or bad materials, sustainable or unsustainable. There are only unsustainable ways of using them, like in most cases nowadays, and sustainable ways of using them. Each material offers possibilities to implement closing the loop strategies, and this should be used in the development of new products. If we're looking at closing the cycle through the biosphere, timber, wood, together with plant and animal fiber tissues, constituted the basic resources for most civilizations prior to the Industrial Revolution. Such materials, when their use is depleted, can be returned into the natural environment that produced it, and after being naturally processed, to be transformed again into the original resource. And we have here the example of the cork. Cork can be extracted from the cork oak without putting its life in risk. This process starts 25 years after it is planted and can be repeated every 9 to 12 years. And a tree which is grown by traditional methods commonly reach its productive life after 2 centuries without any artificial irrigation, using neither herbicides or fertilizers. And currently, the planted cork oak takes up to an area of 2.2 million hectares and is mainly located in Spain and Portugal. A cork oak forest is more than just cork harvesting field, since the natural activity of these trees becomes indispensable in maintaining the ecosystem balance of the arid place they inhabit. By using cork insulation or finishing, we are opting for a renewable and low energy content material, and we are furthermore ensuring the continuity of its production and the subsequent natural landscape preservation. And you have here some pictures with cork oak forests that have been used for years. And you see here there's a picture. This factory has been working for at least 200 years. And you can use cork in many different ways, not only for the bottles of wine, but also as insulation or finishing of the walls. The polishes and paints usually have negative impacts. That includes a significant amount of manufacturing energy, petrol-derived raw materials, consumption, heavy metals, which are incorporated as pigments and have toxic emissions into the atmosphere during both the production phase and the application process due to the evaporation of the organic solvent. However, there is a new generation of products based on natural raw materials that has been developed for decades in Europe, which avoids all the previously mentioned toxic effects. Now, the natural polishes and paints are products whose finish and durability qualities are equal to those of synthetic origins. Their use drastically reduces the environmental impacts, as minimum amounts of energy are employed in its manufacturing process compared to paints based on inorganic solvents. Raw materials derived from plants are used, which are consequently renewable and free of heavy metals. No minerals and oxides from minerals are used as pigments. The release of organic volatile components in the air is smaller, and all its waste is biodegradable and returned to the natural environment to be composted, because most of the lacquers and paints now are using, like I said, organic components, and they're based on water solvent, not on synthetic solvents. No. And talking about natural environment, I don't know how it is in Ukraine or in other parts of the world, but in Romania and globally, there is a big issue with the deforestation. And deforestation is increasing at an annual rate of 1% on the non-certified tropical rainforest, And even though the resources are continuously growing in controlled forests. According to the Wood Importing Association from areas in Central Europe, this is occurring thanks to the independent forestry certification by organizations such as Forest Stewardship Council, or known under the acronym of FSC, or the Sustainable Forestry Initiative, SFI, and the Voluntary Forestry Certification System, PEFC. Certified system assesses forestry practices in accordance to previously established regulations and make it possible for forest management to meet environmental, social, and economic parameters, ensuring a durable health and productivity of the forest. Moreover, wildlife habitat, water quality, and social benefit for the community, such as proper and regular work, is ensured in this forest. So it's good that we're cutting forest, but it's even better if we are replanting what we have been cutting, and maybe even more than what we have been cutting. Because the biosphere has a limited capacity, which is defined by the territory to which it is confined to and by the solar radiation affecting it, the latter being the main source of energy to feed it. And the production must be carried out without diminishing its potential, while at the same time extracting its resources for maximum use. The management of renewable materials demands consideration of the fact that resources extractions implies, apart from the this isolated act, important environmental repercussions. We need to learn from the experience of the integrated biosphere management models. And now we have been talking about the renewable, closing the cycle through renewable materials. Now we will be looking at closing the cycle through technology. And closing the non-renewable material cycle, that is to say, the transformation from waste into resources must be done through industrial processes. And if we're tackling these issues, this involves developing different strategies, designing new processes and products, and implementing alternative policy models. And the mission is to turn our industrial metabolism from a linear system that constantly consumes resources and expels waste into a closed cycle system where the residues do not exist. And this is a very challenging task and goal. And for that, the philosophy is to do only what is necessary. We were talking before about the ceramic tiles and the impact on the environment, you know, looking at the waste, the water consumption, the energy consumption. And a great deal of the ceramic tiles we use frequently offer more technical features than those we really need them and we put them to use. And this is because either operational conditions are not as severe as they are designed for, or because in some cases the material is prematurely replaced due to the changes in fashion or owners' aesthetic preferences. So I'm not sure how many of you have changed the tiles in your bathroom when you bought a new apartment instead of keeping the old ones. And most commonly, when a building, for example, an office building, is changing its owner, or an industrial building, people have the tendency to replace pretty much everything from systems to materials, tiles, wooden floors, etc. So this is a huge waste, and some of these materials are not at the end of the life cycle, and we're scrapping them. But through correct design, the excesses of raw materials and energy consumption during manufacture could be avoided. And talking about doing what's only necessary, there's a Japanese researcher. His name is Emil Ishida from the Japan corporation Inax, who was wondering how to develop a ceramic product to use for the housing facilities. So he developed ceramics that are produced by hydrothermal solidification, hardening through controlled humidity and heat under low temperatures between 500 and 900 centigrades. This is an important environmental advantage because flat ceramics usually are cooked at 1100 to 1800 centigrade, corresponding to an energy consumption that is 6 times larger. So he developed a method to produce tiles at a lower temperature, which is saving 6 times the energy. And of course, we can close this cycle, this loop, by exploiting new mines. This means, for example, steel, like many other metals, has been recycled for decades. It is one of the few resources that regains its value during the whole building deconstruction process by simply sorting it out selectively. Fusion can take place an unlimited number of times without its quality being altered. In fact, production energy can be reduced between 20 to 30% from the fourth recycling process onwards compared to steel manufactured from iron, carbon, limestone, and the low proportion of scrap. Under certain circumstances, dry construction with removable joints, 99 out of every 100 tons of steel in a building is likely to be recovered. That means obtaining 95 tons of new steel by means of the refusion process. This rate of recovery and the preservation of material quality are encouraging companies to change their form of commercialization. The continuation of the recycling process can be ensured by means of steel supplies of construction systems that can be easily dismantled rather than demolished, and the long-term rental contracts instead of purchases. Glass. Approximately 1.2 million tons of glass waste is generated in Europe in the construction industry every year. It is mostly not recycled due to problems in the separation process and the technical difficulties caused by other materials that are adhering to the glass. On the other hand, 9.4 million tons of glass from bottles are collected by an immense network of municipal collection, all of which can be recycled. These numbers have been compiled in 2010, 12 in the EU. So I think now it's a bit more than that, and also the technology has advanced quite a little bit. And this kind of system has been implemented in many cities, and this is a system of municipal collection which reduces new production and reintroduces the recycled glass into the manufacturing of float glass for 25% of the construction industry. The quantity produced could be larger, but it's limited by a degree of purity that is required in this type of glass. And the key to increase glass recycling is waste management at the construction site, where a lot of material is available, and copying urban collection systems by separating it from other materials and collecting it in large volumes. Also, another material which has been recycled for many years, and it's still developing new ways of recycling, it's plastic. And in the production of plastic materials, the petrol, a resource which must be remembered, it's depleting. It's doubly used in two ways, namely as a source of energy to produce plastic, but also as a raw material. The possibilities of reusing and recycling plastics depends on complex technical factors. Most plastics can be recycled, although two important obstacles must be avoided: the low purity of the resource and the availability of a sufficient amount of each type of compound. The industry shows how good quality products can be made from plastic waste, and a good example are the panels and the boards manufactured out of all sorts of plastics, which are coming from municipal waste collection, which are ground and pressed, and are free of glue or adhesive, and are very resistant to changes in humidity. Another example is the acoustic board produced from the agglomeration of diverse polyurethane foam particles, a compound which has a really high acoustic absorption capacity for all sound frequencies. In both cases, they are 100% recycled and can be used within and outside of the construction industry and can again afterwards be completely ground up and pressed again and reused again. We were talking earlier about concrete, and somehow this is the invitation of not only with concrete, but in general, consuming our own waste. Approximately 60% of the weight of a concrete structure building is made up of crushed natural stone. And these are fragments of natural stone extracted from quarries whose technical characteristics are very similar to the products obtained after grinding concrete itself. So, under certain technical and regulatory conditions, a large amount of this natural stone granules can be replaced by a new material that until quite recently was regarded as simply as waste. And this is concrete. In each cubic meter of new concrete that we consume, we need another cubic meter of natural crushed stone. And an important part of it can be replaced, as we have already seen, by recycling used concrete that is often found on the building site, or it can easily be obtained from recycling plants. By recycling concrete, we're diminishing three environmental impacts at the same time: natural rock extraction from quarries, contamination caused by dumping used concrete, and the transport energy used for transporting these materials. And now there's a lot of equipment that are crushing concrete and recycling concrete and sent to the concrete manufacturers. And of course, there's also this philosophy we can look at, and this is doing more with less. And from the environmental point of view, there is no better material than that which we have avoided to use. By diminishing material consumption, both raw materials and energy are saved. There is less pollution and consequently fewer things that need to be recycled. Like I said before, the design has a lot to do with the optimization of the use of the materials, and a lot of the typical construction products and system could be made lighter. By using products with a minimal amount of materials, both raw material extraction and energy consumption is reduced. In addition, by selecting new and improved products, we are also supporting industries that strive to improve the environmental performance of their product. And another place to look, I said earlier, is extending the lifespan of the materials. And aluminium is typically known as a material that has poor environmental properties. Nevertheless, aluminium has two important advantages: its recyclability and durability. Its durability maximizes its use, and its high recyclability reduces the environmental impact by 90%. These characteristics minimize environmental impacts enormously in comparison to other materials with similar use. Aluminum pieces can be melted and reused practically as many times as desired without any noticeable loss of quality. Though many people are not aware, there are products made with 100% recycled aluminum. We don't know, we cannot make the difference. And aluminum durability in external applications such as curtain wall frames is estimated to last approximately 50 years without maintenance, repair, or substitution requirements. And the tasks of this new industry through new demands of sustainability is to recycle non-renewable materials by imitating the great biospheric machine from the natural world and avoiding waste deposit and their associated environmental problems. The ways to achieve this are already becoming evident in numerous products that we use in the building construction industry and new models that we will have to follow in the future to close the materials cycle. So I think we are coming to the end of this presentation, or what was mostly needed to be covered. And I think, yeah, we handle it pretty well. There are a few case studies in this presentation which are showing how reconsidering a neighborhood, the way to build housings in a neighborhood, how to use landscaping in a neighborhood has brought a significant lower impact in the environment. And you will have in this presentation 3 study cases. This one is, from my opinion, one of the most important and which has the most impact on the environment, not only at a local level, individual level, but also at the community level. And this is the analysis of 60 apartments which were to be built in a new social housing complex. And the municipality was looking on how to reduce the CO2 emissions by keeping the same cost of the building, or not to increase more than 5%, but give a huge reduction in CO2 emissions and give the same quality of life to people that are living there. I'm not going to get into this because we're out of time, but you will have it in the presentation, and you can look at it, how these people, the local council has been looking on how to implement an approach in such way to diminish impact. And it started from the urban planners to analyzing materials, the way of designing them, positioning the buildings, and what kind of materials to be used. So I think, Eva, we are at the end of the presentation, and I hope there's still everybody alive after 3 hours of talking. And they can find some useful information. As for me, if there's any question, I will be more than happy to answer your question. I'm still available here.
Thank you so much, Dragos. And yes, if everyone has any questions, please feel free to put them in the chat. Or if anyone is brave enough to ask, I'll give you a chance in a moment. In the meantime, I would like to thank you, Dragos, for being here with us today. I must say that it was really interesting. I think that we do tend to talk these days a lot about the fast fashion, and then we are quite mindful of the everyday items we are using. But as you said, when it comes to replacement of our tiles in a bathroom, we do not feel that it's as outrageous to pick a new model in 20 years. So you really showed us today how to think about the housing, and that maybe what in life of our t-shirt is a fast fashion in life of our buildings, the decades and tens of years tend to be that brief moment in the life of the building, and a minute in life of the planet, of course. So you really, I think, made us quite passionate about this, to investigate new topics. I see there's a question from Ivan. Please, Ivan, go ahead.
Yes, hi. My name is Victoria. I always use my husband's.
No worries.
Yes, iPad. So thank you very much for your presentation. I don't know if I need to start my video. Okay, without video. Thank you very much. It was really interesting, and I understood that the main approach is to recycle everything. Am I right?
Well, there are several approaches. Recycling is it's one direction, but it's not only one direction we really need to look at. I think the most important step is bring together at the same table all the parties which are involved in bringing to life a project, bringing to life either a building, either a neighborhood, either a region. And for this, you need the designer, you need the urban planner, you need the manufacturer, you need also the developer, because each party has a different view, concept, and goal at the end of the day. And all these visions and goals have to be put together. This would be one part of the discussion. The other one, it's related to materials, of course. And of course, recycling material, it's a must these days. But also using renewable materials, not only recyclable materials, is also a discussion. And also change our philosophy about how we're looking at life, mostly not about construction. It's our philosophy about life. It's the way how each of us is doing or taking their life. How much waste I'm leaving behind me? How do I look at the world around me? And if our inner philosophy it's a bit different, then the biggest philosophy can be different. And this is by creating space for other people to grow, and also to invite other people to be part of a community that thinks in the same way. I think there's many places to approach, many layers for this approach.
Yeah, it's more complicated. And
Well, I would not say complicated. I would say complex, which is different than complicated. Complex can be beautiful.
And complicated.
Yes, sometimes it might be also complicated.
Yeah, and I have also a second question. It's from my life. For example, as I understood about roofs, the question about roofs. In the future, we will use like solar panels for roofs, but I'm thinking it need to be like replaced every 15 or 20 years, I don't know, but
15.
it will be waste for nature again.
Yes.
And for example, one more example from my life, my grandma has a roof from aluminium, and she said, okay, it is for whole my life and for whole my like grandkids' life roof. And my parents have metal roof, and they said it's more like modern and colors so nice. And in Norway and Sweden, I saw on old houses roofs with moss and grass on the top. Did you see this? And comparing all these roofs, what's your opinion? What type of roofs more ecological, attractive?
Well, this is also a discussion. Thank you for the question. It's a very good question. Well, it depends also where we are building these houses. So if I'm building a house which is in a mountain area and I have mainly rocks, I cannot put grass and land on it. So I need to find a different roofing system for that. And what I can put on my roof, it can be either wood, sheets of wood, which can be isolating also, or we can put stones, sheets of stone. But that's specific to the region where we're building this. Of course, grass and land from an ecological point of view and from an insulating point of view, it's the perfect solution. But we cannot use that in all the places we're using. In a very hot areas, for example, you cannot use this kind of insulation because it will cost you more to maintain that roof than to put a metal roof or a different sheet roof. So it's important to adapt locally the solution of the building where you develop the project. It's not this one is better than the other. It's what it's really needed in the area, the solution. And of course, aluminium roof, it's for life. It's for even for 2 lives. But the cost of the aluminium, it's extremely big compared to using, you know, land and green roof, or using, you know, I don't know, something different. So you need to put in balance and to use an analysis, the life cycle analysis of the project in the local environment where you are building. There are not solutions which are tailored for every places in the world. They need to be specifically adapted. So the invitation is to be creative and to find which would be the best solution for the place you are developing a house or a building, in order to have a good quality of life, but also to have a lower impact on the environment.
Yeah, thank you very much.
Thank you.
Thank you, Dragos. I think that you very nicely wrapped this up, and then also explained in a very nice, coherent way that the philosophy of the Smarter for EU project and the green certification that the project is trying to work with. So we are hoping that this conversation is really just the start of the further cooperation, especially with some of the municipalities which are here today on the call. The Smarter project is able to provide also more individual cooperation and consultations on the right mix for your project. I just echo the many nice thank you messages I see in the chat here. So going forward, we are going to distribute the presentation as well as the recording. Maybe just be a little bit more patient with the recording. We are trying to now summarize and put into one place all the recordings from the previous courses as well. As it was said at the beginning, we are going to distribute a form where you can indicate in which courses you took part in order to receive the certification with the list of trainings you successfully passed. So that's it. Maybe actually one last thing, just a little announcement. We are going to be in touch with you again for the official opening of our green certification in Ukraine. So for those from Ukraine listening, it will most likely happen the week of March 11th. We are yet to set the date. It will be an online event where you're going to meet with a few more colleagues from Smarter for EU project, besides the energy efficient cities of Ukraine, also the UEA and another Ukrainian partner. So we are hoping to continue this conversation and have a few more individual follow-ups with some of you if there will be an interest. So that's it from me. Everyone, I wish you a very nice day, and I'm hoping to stay in touch. Dragos, thank you again.
And thank you again for me also, and I wish you all the best with your projects, and for everybody, you know, have a great time, and be curious and take care of yourself.
Thank you.
Thank
Bye.
you. Bye-bye.
Thank you, guys. It was extraordinary. Thank you. Oh, it's so fast.